Getting just one variable wrong can absolutely wreck an entire experiment. In the next few minutes, I'm going to show you exactly how to nail all 5 required practicals for your GCSE Physics Paper 2 exam.
Look, these practicals are easy marks, but only if you know the method inside out. Let's dive straight into the first one, Hooke's Law. So this one's all about a simple question. How much does a spring stretch when you pull on it? It's all because of something called parallax error. It's a super common mistake, but it's also incredibly easy to avoid. Here's the perfect method.
Okay, step 1. Get your ruler and spring clamped so they're perfectly parallel. Step 2, and this is the crucial part, get your eyes down to level with the bottom of the spring to take your first reading. Now add a mass and measure the new length, again at eye level. To find the extension, just subtract the first number from the second. Easy. Then just keep adding more weights to get all your data points. Right, you have to know your variables. The independent variable is the force. That's the weights you're changing. The dependent is the extension. That's the result you're measuring. And you control? Simple. You have to use the exact same spring for the whole experiment. And here is the money phrase for the exam. When you plot your graph, if it's a straight line that goes right through the origin, it means force and extension are directly proportional. You have to use those exact words.
So we've mastered force on a spring. Now let's look at a moving trolley. It's time for Practical 2, Force and Acceleration.
This is a classic exam trap. So many people get this wrong, but the solution is actually really simple, and it's the key to making it a fair test.
Measuring acceleration is a 4-step process. First, you've got to release the trolley from the exact same starting point every time. Second, you time how long it takes to travel between 2 markers. Third, use light gates to get the change in velocity between those same 2 markers. And finally, to calculate acceleration, you just divide that change in velocity by the time it took.
Now here's the clever bit. If you want to change the force but keep the total mass of the system the same, you move weights from the trolley to the hanger. But if you want to change the mass, you add new weights onto the trolley and keep the force on the hanger exactly the same. And for this one, your number 1 most important control variable is the slope. That ramp angle has to be absolutely identical for every single run, or all your results will be useless.
Okay, we've done forces in motion. Let's move on to energy transfer with Practical 3, Waves in Action.
Because trying to measure a single, tiny, moving wave is a recipe for disaster. Your measurement will just be way too inaccurate. The secret is to measure in bulk.
So for a ripple tank, always think bulk. To get frequency, count how many waves pass a point in 10 seconds, then just divide by 10. For wavelength, freeze the image, measure the total length of 10 waves, and divide by 10. Then you just multiply your 2 answers together to get the wave speed.
Now, the string method is actually a bit quicker. See, the signal generator just tells you the frequency, so there's no counting needed. All you have to do is measure the wavelength. And the key thing to remember here is that 2 of those loops you see is equal to 1 full wavelength.
And yup, just like with the spring, our old friend parallax error is back. When you're measuring the wavelength with a ruler, you have to be looking straight down at it, from directly above. No angles.
From waves we can see in water, we're now moving to a wave we can't see, infrared radiation. This is all about heat transfer.
Okay, let's clear this up first because so many people get it mixed up. Emitting is all about how fast something cools down. So you start with hot water. Absorbing is about how fast something heats up. So you start with cold water and a heater.
The method for both is almost exactly the same. You fill different cans with the same amount of water, you put them in position, and for absorbing, make sure they're all the same distance from the heater. Then you just record the temperature change over a set time, like 5 minutes. Whichever surface has the biggest temperature change is your winner. It's the best emitter, or absorber.
And the big exam takeaway, the one thing you absolutely have to remember, the best surface for both emitting and absorbing infrared radiation is always matte black. The worst is shiny silver. That's a guaranteed mark right there.
Okay, our final practical. And a quick heads up, this one's for separate science students only. It's all about what light does when it hits a surface.
The basic method works for both experiments. You pop your block or mirror on some paper and draw around it. Then, draw your normal line that's at 90 degrees to the surface. Shine a ray of light in, and mark the incoming and outgoing paths with a couple of X's. Then, you just take the block away, join the dots with a ruler, and measure your new angle.
The results couldn't be simpler. For reflection, the light ray bounces.
That means the angle of incidence equals the angle of reflection. For refraction, the light ray bends as it goes through the block. This means the angle of incidence is always bigger than the angle of refraction.
So, there you go. You've got the perfect methods for all 5 practicals. But the real test in your exam is this. Can you take what you know now and spot the deliberate mistakes when they describe a flawed experiment in a question? That's what separates a good grade from a great one.